Okay, here we go with homework 15. The first question, parts A, B and C, they all just rely on the rules that log to the base A of x plus log to the base A of y is log to the base A of x times y. And log to the base A of x take away log to the base A of y is log to the base A of x over y. And then in part C, that's using the rule which says log to the base A of x to the power b is just b log to the base A of x. So if you stick to these three rules, that should get you to the answer for question 1. Question 2, if you remember the rule which says log to the base A of b equals c, then you should know that a to the power c is equal to b. So if you take the question, let's take one similar to the first one. Log to the base x of 8 equals 2. Now if I write it in this form here, okay, a to the power c equals b, then what I would have would be, so let's make that 3, x to the power 3 equals 8, therefore x must be the cube root of 8, which we know is 2. Okay, so if you rewrite the logs as an exponential function, so take the log, make it an exponential function, and then just solve the little equation that comes from that. Question 3, that's back to log to the base A of x to the power n equals n log to the base A of x. But first of all you have to use the add rule. So use the add rule first of all by multiplying the x squared and the x to the power 5, and then use the rule about the indices. Now question 4. This is going to test your algebra skills. We have the straight line y equals mx take away 4, and we have the circle x squared plus y squared minus 2x minus 6y plus 5 is equal to 0. Now if we're trying to find any place where lines and circles intersect, then we must substitute the line into the equation. So it's going to become x squared plus mx minus 4 squared minus 2x minus 6 times mx minus 4 plus 5 is equal to 0. Now you need to remove all of these brackets that are here and then tidy it all up. Why do you need to do that? Because if it's a tangent, right, we know that a tangent means there's only one point of contact. One point of contact means equal roots. Equal roots mean b squared minus 4ac is equal to 0. So once you've removed all the brackets here and tidied it all up, you then have to identify what your a is, what your b is, and what your c is. And then once you've got those numbers, you then put a in here, c in here, and b in here, and then you solve that quadratic. Now I'm warning you, there's a lot of algebra in here, so take care, don't make any mistakes, and if you get numbers like 196 and 180 appearing, then you know you're on the right track. But it's quite long, it's quite involved. Question 5, a bit simpler. Perpendicular vectors happen when the dot product is equal to 0. So we're going to take each of the vectors, 2, 3, negative 1, and 3, minus 1, 3, and we're going to dot them together, and hopefully we're going to get 0 coming out. And remember, the way we dot them is we do that times that, that times that, that times that, and then add them all together. So a times sum, then an add, a times sum, then an add, another times sum, and hopefully you should end up with 0. Question 6. take the two triangles and separate them. We know from the diagram that this is side 4 and this is side 3, and we also know from the diagram that this triangle is side 4. Okay, let me draw you what we had to start with. 3, 4 and 4. Now the bottom of this triangle here is the hypotenuse of this triangle. Now we can do a bit of work on Pythagoras to get that side as 5, so that means this bottom side here is 5. Once we know the bottom side there is 5, then we can work out that sloping side there. Once we've got all that information, we can go into sin x plus y equals, do the expansion, sin x cos y plus cos x sin y, put the fractions in, simplify it all out. Question 7, just remove the brackets, cos times cos, cos times sin, sin times cos, sin times sin, tidy it all up, you should get the answer. It's fairly easy. Question 8, I've done a few of these, so do the expansion, cos x, cos alpha, plus, don't forget the k, sin x, sin alpha, then identify your k sin alpha, identify your k cos alpha, and then work out k squared and then eventually k, tan alpha and eventually alpha. Should be okay, that one. Lastly, question 9, one of these half-life problems. Here we have the formula that carbon left after t years is equal to the amount at the start, e the kt. Now the question says it's the half-life. So if we assume that we started with 100%, say, and then ct is how much would be left after one half-life, so it would decrease by half, so it would go down to 50. And we are trying to find k. So if you put these numbers, 50 equals 100 e to the 5730t, you should be able to solve that to work out, oops, sorry, I should have a k here, put t in. You should be able to solve that to get what k equals. Now remember, keep a decent number of decimal places in your answer. This one comes out to be negative 0.000. I'd keep at least another 3 digits there. Okay. And then you repeat the question once again for the second part. Second part is, you know that there's 85% left. So let's say again we started with 100%. CT, 85% left. T, that's what we're trying to find this time. And K is your answer that you got from up here. Plugging those into the formula and working it through like you did above should give you how old that bone is in the garden. That's us this week.